bases. It is corrosive in nature. It is sour in taste. It can corrode the surface on which it falls.
It
So
can be
these things,
dissolved.
it can be diluted, right? And it can be dissolved in water. Okay, say I have given you a concentrated sample of some acid. Let's say I have given you hydrochloric acid. It's a strong acid. And I ask you to dilute it, make it weaker. How would you do that?
Put base in.
Put base in it.
Sir?
Yeah.
Is it water?
You have to add water to it now. But what is the correct way of diluting the acid? Should you be adding water into acid, or should you be adding acid into water? What is the correct method? Yeah.
Water into acid?
You have to add water into acids. No, you have to add acid into water. No.
Yes, sir. Yes, sir.
See, you have to add acid into water. If you were to do the other opposite, it would be very explosive and can harm you. Right now? Okay, then
Yes.
I did told you about different types of acids. Some of the acids are found in natural sources. Okay, can you guys tell me what acid is found in amla or in citrus fruits? What acid is found?
Citric acid.
Citric acid is found. Okay. What about vinegar?
Acetic acid.
Acetic acid. Very good. Okay. What about tamarind? Tamarind, grapes,
Tartaric acid.
tartaric acid. Very good. Okay. What about sting of ant sting, or beetle sting, or wasps sting? Not beetle, bees in sting.
Formic acid.
Not formatic. It's formic acid. Okay. Formic acid. Okay. Now, then to tell me about what about unripe apples? Apple which hasn't which is not ripe.
Sir,
Unripe
tartaric.
apple. No, it's not tartaric. And unripe apples, I haven't told you about this one. Let me add that one into it.
Yes.
So that is malic acid. Okay, no?
Okay.
Unripe apple consists of malic acid. Right now. So then tell me about this also. Sour milk or curd. What acid is found in curd?
Lactic acid.
Lactic acid. Very good. Also, you guys know, like, natural acids are weak acids, and we call them as organic acids also. So keep that thing in mind also. Like, it has got multiple names. Organic acids. While the synthetic acids,
Sir?
we'll be calling them as, yes,
Sir, but then malic
organic
acid.
acids.
Sir,
Repeat
but
again.
then Sir, but then malic acids are not sour.
Malic acids are not sour. See, malic, it does not has got to do with the taste exactly. In this case, see, for example, if I were to talk to you about this now, for example, there's an acid called as carbonic acid. It's a very weak organic acid, and it can be prepared by dissolving carbon dioxide into water. Carbon dioxide dissolves very easily in the cold water. So hence you would find that in soft drinks or in soda, carbon dioxide is found, and it is an acidic. It is an acid. What I basically want to say to you here is that it does not exactly has got to do with taste in some case right now. So malic acid is actually found there in unripe apples. It is found in the berries also. Okay, now. Apart from that also,
Sir,
malic
that's
acid is
why,
found in different source. Yes. Let me just complete this thing.
Sir, that's why when
So malic acid will be found in watermelons also. It will be found in fruits like broccoli also, or in carrots also. So does carrots taste sour?
Not that much, sir.
Not that much, no? Or you
Yes,
have
sir.
broccoli, you would have eaten broccoli. Broccoli also does not taste sour usually. Or watermelon also does not taste sour that much. Yes, Abu, complete your question.
Sir, that's why,
Uh-huh.
because what when you put like water and then carbon dioxide in it, it is like in soda, it is acid, and then you can find it out. It is an acid because when you drink it, you have a tingling sensation on the tongue.
Tingling sensation or burps. Uh, you start burping. Hmm, that is the thing, correct. Also, many times butter also gets spoiled. Did you guys wrote the types of acids yesterday? I told. Okay, we're not able to wrote the types of acids, no?
Yes, sir.
No, sir.
Okay, do one thing. After the class, I will be providing you a screenshot. Make sure you note that in your copy. Okay. So leave some space for that. Leave one page for the types of acids. Okay, na?
Okay.
From after that, you will be continuing. Right. So we did talked about the two. Now, out of organic or inorganic acids, which one will be stronger? Which one will be stronger out of organic and inorganic acid?
Inorganic.
Inorganic, obviously. So we had several examples of inorganic acids. Like you had example of hydrochloric acid, that is HCl, hydrochloric acid. Then you have examples of nitric acid, that is HNO3, that is nitric acid, right now. Or you have example of phosphoric acid or sulfuric acid. Sulfuric acid is H2SO4, that is sulfuric acid. Apart from these, you have one example of phosphoric acid also, right? And that is H3PO4. That is phosphoric acid. So it is quite easy to remember the names of inorganic acids also. The three most common one are hydrochloric acid, nitric acid, and sulfuric acid. At least you should remember the names of first three. Okay, na? In soda, what type of acids are found in soda water? Soda water or soft drinks? It basically is carbon dioxide along with water. We call them as carbonic acid. Okay, now,
Okay, sir.
and usually it's a weak acid. Okay, that is the thing. Now, talking about some of the inorganic acids, you know that we are able to store the inorganic acids in glass, in beakers, in test tubes. Usually in the chemistry lab, you will find we can store them in glass. So is it that acids cannot dissolve glass? See, that is not always the case. You have some of the examples of acids which are so strong in which even glass is soluble. Even glass is soluble. Getting it, guys, what I'm trying to say. Okay, now? So thereby you cannot store that acid in glass bottles. So they would be kept in bottles made up of plastic containers, or Teflon bottles would be used. Bottles made up of Teflon. So there's a very special type of acid you should know. The name of the acid is hydrofluoric acid. Hydrofluoric acid. What is special about this acid, Priyanka? What is so special about this acid?
So it's very strong. It could break the glass.
Not break it, basically will dissolve the glasses. Okay, no?
Okay, sir.
In fact, it is said to be the only liquid in which glass is dissolved. So how you would be storing such an acid? But it is stored in Teflon bottles, right?
Sir,
The
what is
Teflon bottles,
the most strongest?
which is the
Uh,
most strongest acid.
yes, sir.
Okay, that is, I believe it starts from somewhere, goes like antimony pentafluoride. I believe it is antimony pentafluoride, I think, or maybe it's a fluoroantimonic acid. Guys, I will be back in a minute. There's someone on the door. Okay, na?
Okay, sir.
Yes, I'm back. Yeah, please continue your question. Yes, Abu and Priyanka. Guys, I believe I'm audible to both of you.
Yes, sir.
Mhm. You guys were asking a question.
Abubakar was
Yes,
asking, sir.
Mhm.
what is the most?
Yeah, there's an acid. I believe that goes by the name fluoroantimonic, somewhat like that. Fluoroantimonic acid, I think. Okay, now we'll confirm that in the next class. And also, it's not like a pure acid. It is prepared by the mixture of different acids, right now. So it's a super acid. It's a kind of super acid.
Sir, is it rare to be found?
Is it?
Sir, some acids are not allowed even on lab, even in labs because of.
Mhm. Because of see, if the glass were to break, or if someone were to inhale the fumes coming out of it, that would be very deadly. That can even lead to death. So some of the
Yes, sir.
acids, Mhm.
e-
so you
Even
won't
it could
have access
change
to
the
it.
color of. Yes, sir.
Exactly, right now.
Sir, what about hydrofluoric acid?
What is?
What about hydrofluoric acid? It's not strong enough.
See, even if it is strong, but even there are acids which are stronger than hydrofluoric acid. There are acids which are even stronger than this right now. So that is the thing. But it is said that hydrofluoric acid is the only liquid in which glass is dissolved right now. So while fluoro and antimonic acid is also there, but we will have to look at its properties. Then we can say whether it will be able to dissolve glass or not. Right? Okay. Any other questions?
Yes, sir. Sir, I have one question.
Yeah.
Sir, my teacher said that. Uh, Sir, my teacher said that like uh, if you put an acid and an acid on top of the gold, then the gold's the color would change. Then I asked her, then what color would it become? Then she did not know.
Okay. Like what will be the change in color of gold if it gets in contact with an acid?
Yes, sir.
Okay, see. First and foremost, you need to know that usually gold does not react with acids, but it will be reacting only with the aqua regia. It can be dissolved in an aqua regia, which is a very concentrated acid prepared by mixing hydrochloric acid and nitric acid. See, if you were to take this hydrochloric acid and then you take nitric acid, you mix these two, you will get a very strong substance called as aqua regia. Now coming to your question, what will be the color change? See, even if I were to use any of the concentrated acids, gradually it will start to eat the surface of the gold. But what color it will change into, it depends upon the type of the metal that has been used to prepare that gold ornament. You know that pure gold exists in the liquid state. Pure gold, it exists in the liquid state now. Pure
No, sir.
gold means no impurity in it. If I were to talk about pure gold, so thereby it means that it should not consist of any other metals in it. Get that thing clear first of all. See, for example, usually copper would be used as the base metal in order to prepare gold jewelries. For example, if the acid turns the color of the gold into green, this will indicate that the gold that you are having, it is not made up of a very pure metal. Getting in what I'm trying to say? Usually, it is seen that it might change to green in color. Hmm?
Yes, sir.
Getting it now?
Sir, but then,
Mhm.
sir, but then the purest gold is 24 karat. So then, sir, it is 24 karat is not liquid. It
So
is,
that,
it is not fully like liquid state.
see, if you were to talk about liquid gold, so when we talk about liquid gold, na, you would find that see, whenever gold is mined out, whenever mining of gold is done, so you would have the small pieces of gold like this. But inside that gold also there would be several impurities, like there would be some amount of iron, there would be some amount of copper, there could be some amount of zinc. These are unwanted substances, right? And it's the presence of another metals in the gold that enables it to exist in the solid state. If you were to eliminate all the other metals from it, it would exist in a liquid state. Getting it what I'm trying to say? Hmm?
Yes, sir. So then that state is 24 karat, right?
No, that isn't. 24 karat gold consists of other metals also. If you were to talk about composition of 24 karat gold, so it is said to be pure gold with we say that it does not consist of other metals, but the thing is that it will consist a tiny amount of some other metals. Usually we say that 24 karat gold is the purest form of gold in which no other metals are found right now, but
Yes, sir.
it will consist a tiny amount of it. We also say it is 100% pure gold, but in local market it is, you will find that it is 99.9% pure right now. All, and it will be expensive than 22 or 18 karat gold right now. So
Yes,
that
sir.
is the thing. Also, in your answer to the beginning question, that whether the color of
Yes,
gold will change in coming in contact with acid or not, the answer to that lies that gold does not react with any single acid. It will react only with the mixture of hydrochloric and nitric acid. The mixture is called as aqua regia. So this mixture is so strong that it dissolves gold in it. Gold basically gets dissolved in it and it turns into something else. And what color will change? For example, if I were to take some gold and keep in contact with an acid for a very long period of time, so gradually it will start to eat the surface and it will come in contact with the metals and thereby will turn the color. It might usually change the color into green or sometime blue, but depending upon the metal found inside it. While in the case of 24 karat gold, you won't observe any color changes because it does not usually contain of, it is said that it does not usually contain any other metal, but a very tiny fraction of it may be present in it. Okay, na? So purest form of gold exists in liquid state. Keep that thing also in mind. Okay, na?
So why you cannot buy that?
Why we can't buy that? How would be using that?
Sir, without using, just keeping it. Sir, as we
Um,
have coins of gold coins.
in that manner also you can do that, but it has to.
Sir, then they,
Mhm.
sir, but then they do not sell it.
It is not sold in that manner. Okay, no, it is not sold in that manner in the market. Okay, let us continue further then. Yes.
But, sir, I've went to the
Okay.
market.
And
Market.
to purchase gold.
Yes, sir. Gold. So, sir, it is the cheapest place for gold in the world.
Uh, that is, I believe, Riyadh,
No, sir, in UAE.
UAE. In
Yes, sir.
UAE,
Or
in UAE where?
sir, in UAE, Dubai.
In Dubai. Okay, okay. So Dubai is the cheapest place to buy gold.
Yes.
Okay, okay,
No, not Dubai. Gold souk. Inside there is one place called Gold Souk over there.
okay, okay. Anyways, by the way, no, I have got no idea regarding that. Okay. Now, let us continue further. And do tell me, we did talked about this thing also. How would you be testing whether a substance is acid or base, whether it is an acid or not? So we had the litmus test conducted. So do tell me, if the blue litmus turns red in color, what does it mean? Is it acidic or basic?
Sir,
Acidic.
acid.
Acidic. Okay, now do tell me one more thing. Say that if you have acid in the dry state, if you have an acid in the dry state, it is not in the form of a solution. Thereby, will it show any change in litmus paper or any other indicator?
No.
No, sir.
So keep that thing also in mind, that acids in anhydrous.
Sir, we should
Anhydrous means that, yes,
we write.
in that, no, at this point. So acids in anhydrous form do not act on litmus or any other indicator. So that is the thing. By the way, you
Yeah.
guys know where did this term acid came from? Where it was derived?
No, sir.
It has been derived from a Latin term. Derived from a Latin term, that is acidus. Okay, no. So in Latin, acid is acidus. So acid. So basically, acidus. Acid comes from the Latin word acidus, right now. So in
Sir,
Latin, acidus basically means something that is sour in taste. So that is the case. Yes, Priyanka.
sir, can you read acid in after acid in? Acids in.
Acids in anhydrous form, anhydrous. So acids in anhydrous form do not act on litmus or any other indicator. Anhydrous, basically you can write it as dry also. Before anhydrous, you would be writing it dry. Okay, no? Then also we learned in the previous class, I would like to add one more important thing into this. See, all the acids, whether it be organic or inorganic, whether it be a weak or strong acid, they would be releasing hydrogen ions in water. Once they are in the soluble, once they are in the form of solution, they would be releasing hydrogen ions in the water. So hence an acid is sometimes also defined as a substance which gives out hydrogen ions when it is dissolved in water. Let me clarify it further. See, I have an acid, let's say HCl is an acid, and it is made up of the ions of hydrogen and ions of chlorine. Ions are basically charged atoms. You can understand it in this manner. Ions are basically charged particles. What are ions? Isabu and Priyanka?
Charged
Sir,
particle.
because
Charged particles. So whenever an acid is in the liquid state, or if you were to add water to it, what will happen? Acids start to break it into ions, right now. So all acids, whether it be organic or whether it be organic or inorganic, whether it be weak or strong, where they would be releasing hydrogen ions in water, right now. See, these are the hydrogen ions. Okay, na? So a substance, we sometimes define acid as a substance which gives out hydrogen ions when they are dissolved in water. Now, if you were to look at these acids, hydrochloric acid, sulfuric, nitric acid, phosphoric acid, or hydrofluoric acids, these are the acids that would release a large number of hydrogen ions in water. What do? They release a large number of hydrogen ions in water. So that is also one of the reason why they are stronger. So some of the interesting facts are as follows. Right now we have discussed that acids releases H plus, that is hydrogen ions in water. Have you guys observed this thing over here? Have you guys observed this thing? Like if you were to have a beaker of water, or let's say you have some acid in this, you put two metal rods in this and you connect this metal rod to a battery. You will see some movement in this acid, or if it's a basic solution also, you will see some movement in it. What are those movements? Those movements will be due to the ions. Getting it, guys, what I'm trying to say? Let me show you an image of it, otherwise you won't get the complete picture. So as of now, while I'm loading the picture, do tell me which acid will release more hydrogen ions in water, organic or inorganic?
Inorganic.
Inorganic, right now. See this one over here. You have taken a sample of hydrochloric acid, okay, na? And it is in the aqueous state, meaning that it is not dry. It consists of water. Okay. So what you will find here, that in the water is in the aqueous state, it gives out ions. It will be giving out ions. What ions it will be giving out? It will be giving out ions of hydrogen, and it will be giving out ions of chlorine. But we have to focus only on the hydrogen ions. The one that will be releasing more hydrogen ions, they are stronger. The one that will be releasing less number of hydrogen ions, they are weak acids. So you have organic acids like acetic acid, citric acid, tartaric acid, malic acid, lactic acid. All of them are weak acids and they release less number of hydrogen ions. Is that clear to everyone now?
Yes, sir.
Okay, no? Now, what were the physical properties of acids? We should know about the physical properties of acids also.
Yes, sir.
Physical properties of acids. So first thing is that they are soluble in water. Okay, now all the acids are soluble in water. So acids are soluble in water. Next thing is that acids are usually colorless. Although sulfuric acid maybe sometimes it could be brownish in color due to the presence of impurities in it. And now you would say like, sir, you have got acids, uh, some type of acids that comes in yellow color. Huh? You would say that some types of acids are used to clean marble, to clean some people would be using at like railway stations or at various places. It would be used to clean washrooms. Hmm? So
Yes, sir.
why some acids are colorful? Yeah. So the reason is that they are made colorful on purpose so that one can identify it and do not mistake it for water or for something else. Getting it what I'm trying to say? So certain color would be added in some acids in order so that it can be distinguished from other liquids so that people don't confuse it for something else, right now? But naturally all the acids would be colorless except for sulfuric acid. Is that clear? So all acids are colorless except for which one? Sulfuric acid. Okay, now. And then why it? What color it will be having? It will be having a brown color. What is the reason behind this? Due to impurities. I hope you guys are on the. You guys are grasping the concepts. Huh? Then the third thing about them is that acids taste sour. We have learned about that. Regarding the action of acid on indicator, it will be turning blue litmus paper into red. I hope I'm audible to both of you.
Yes, sir.
So it converts blue litmus to red. Later on, when we would be studying about indicators, there we would be studying about an indicator, methyl orange. So it will be converting the methyl orange into pink. Right now, just note this thing down. Once I get to that part of the chapter, there I would be discussing it with you guys. Okay, now?
Sir,
So you guys are not required to note this thing down, the physical properties of acids.
sir, should we leave one page?
The one page that you left for the types of acids, after that you leave, you write the physical properties of acids. Okay, now?
Okay, sir.
There are some other physical properties also, like acids are corrosive. Most important, which we learned moments ago, that acids releases hydrogen ions in water. Okay, now? Then you know, like there are some acids. For example, you have sulfuric acid. It is oily. Sulfuric acid is oily and it will be heavier than water. So sulfuric acid is oily and heavier than water. And last most important thing about them is that the pH value, we'll be learning about pH scale also. As of now, just write this thing down. As we proceed further, we'll be learning about it as well. So pH range of acid is 1 to 6. Write this much and do let me know once you guys are done.
Okay.
You guys know it is usually advised, and it is usually advised not to serve tea in copper cups. Have you heard of this? Like, tea should not be served in copper cups. Yes, Abu? Priyanka?
Yes, sir.
Or food should not be stored in containers, metal containers. Especially the liquid food items should not be kept in containers made up of copper or tin. Huh? The reason why it is said that, again, food should it is advised that a cooked food of, especially the sour food that is a bit acidic food which is acidic in nature, it should not be kept in brass or copper utensils. The reason is that acids react with metal and corrode them. Okay, na? So what will happen, na, guys? Like copper, upon reaction with acids, will form copper salts. It forms copper salts, and copper salts are poisonous. Apart from being poisonous, it spoils the taste of the food also. That is why we should not store the liquid food in metallic containers. Even tea should not be served in the copper cups. Am I clear to all of you?
Sir,
Yes.
is it harmful?
Is it harmful? Copper salts,
Sir, that you told that it will be like
poisonous.
yeah, poisonous.
So obviously it is harmful, right now. If there will be too much of copper salt, then it can be deadly. It can be lethal for the health. Okay, now.
Okay.
So it can be problematic for the health, right now. Now there are some additional interesting things I would like to tell you. You know, it was the scientist Robert Boyle who was the first person to have studied the properties of acids in so much of detail. There was a person called as Robert Boyle. You guys done writing all this?
No, sir.
Okay, okay. See, I'm thinking now in another class also we would be still discussing about acids, because in the later part of the chapter I was about to discuss that, but the next class also we will be continuing from acid only, because we have to discuss about chemical properties of acids also. Right now we are discussing only physical properties. Then you would be learning about uses of acids also. Okay, no? By the way, you guys please to let me know what are the topics that were discussed in your school in acids and bases. Did you guys studied about the chemical properties of acids?
Sir,
Yes, Priyanka.
actually, we just started and we wrote 2 questions.
Oh,
Today and tomorrow is holiday for us.
okay, okay, got it.
So
Abu, the
we got
chapter.
later.
Okay, Priyanka, got it. Abu, what about your chapter? Heat is finished or not?
No,
Not yet.
sir, it has just started some days ago.
Okay, it was started few days ago only. Okay. So I am thinking
No,
how
sir,
about.
like,
Mhm.
sir, it has finished, but then, sir, like, for my teacher, like, like, she did not explain the chapter heat like very thoroughly. Like, she has like to finish the syllabus fast. She has just like taught us like some of the part of the chapter. Then she have started acid and base.
Okay, got it. So she basically taught the chapter in a hasty manner, very quickly, not in depth.
Yes, sir.
Okay. Do tell me, you guys understood the chapter heat properly or not?
Yes, sir.
Good. Do let me know once you guys have noted it down. So I was talking about the scientist Robert Boyle. He was the first person to have studied about the properties of acids and bases. He described that acids are sour in taste, they are corrosive in nature, and it turns blue litmus paper into red color. Right now. It was later on there was one more scientist, Lavoisier also came. He was basically a chemist. Chemist is a person who is well versed in the field of chemistry, who studies chemicals, chemical reactions, and all that. So later on, Lavoisier went on to say that water was an essential part of an acid. He stated that he was Lavoisier stated that water was an important part of the acid. If water is present in the acid, then it will be showing its properties. For an acid to be corrosive, it has to be in an aqueous state. It meaning that it needs to have water in it. Only then it will show its corrosive property, or only then it will be turning blue litmus paper to red, etc. So Lavoisier said this thing. Later on, some more scientists came and they went on to say that it is not the water, but it is the hydrogen which is essential part of an acid, which determines the properties of an acid. You guys getting now what is the sequence of the things that is going on? First of all, Robert Boyle came to study the acids. He studied the properties of acids, described them as sour, corrosive in nature. It turns blue litmus into red. After Robert Boyle, another chemist came. His name was Lavoisier. You would be getting familiar with the name of Lavoisier in your higher classes. In class 11th and 12th, particularly, you would be learning in detail about him. Okay, na? He had so much of contribution in the field of chemistry. So Lavoisier went on to say that water is an essential part of an acid, right? So he said that whenever you have some non-metals, for example, you have different kind of non-metals like chlorine, or you have some other ones also. Basically, the thing about Lavoisier was that he said that water was an essential part of an acid. Later on, another scientist came. I'm forgetting the name of that scientist, but that scientist basically said that it's not actually water. To be precise, it is hydrogen that is an essential part of an acid. And in fact, we did learn about this also, no? Acids releases hydrogen ions in water. Okay. Which points you guys are writing? How many points you guys have wrote?
Sir,
Yes, Priyanka.
can you read the ninth one?
Ninth one, yeah, sure. It says pH range of acid is 1 to 6.
Okay, sir, done.
Done? Good. Abu, you done? Yes, Abu, done or not? Next, we're going to learn about the chemical properties of acids. Okay, now. So, see, if you were to take a sulfuric acid, or you say that you were to take hydrochloric acid. You take a sample of hydrochloric acid and you add some granules of zinc in it. You add some granules of zinc in it, you will observe that it will start to give off lots of gas. It will start to release some gas right now. So that's what we are going to learn right now. Let me show you this activity. Right now we are going to discuss about the chemical properties of acids. Okay, now in this, let us learn reaction of Zn actually. See, in this test tube we have taken hydrochloric acid and we have taken some zinc granules. If I were to zoom it out, you can observe that some bubbles are formed in this. Can you guys observe that?
Yes, sir.
Hmm? Abu, some bubbles are formed in this now. So you have taken some zinc granules. Okay, now there are some zinc granules in it. Zinc. Zinc granules basically are small particles of zinc. It reacts with the hydrochloric acid. A chemical reaction is taking place here. What chemical reaction is taking place? This thing is happening. Zinc in short is written as capital Z and a small n, that is zinc, plus HCl. It reacts to form a salt. What does it form? It forms a salt. That is ZnCl2, or the chemical name is zinc chloride. Along with that, it the bubbles that we're forming, remember we did talked about this? These bubbles are of hydrogen gas. Okay, now? So these are hydrogen gas. So hydrogen gas is formed in it. Also, we did remember that hydrogen ions are found in the acids now. So you can relate from there also. So right now we have discussed the first property of acids. Right now we are discussing about the chemical properties of acids. In the first one, what we saw, that acids would be reacting with metal. Zinc is a metal or not? Zinc is a metal, no? So zinc is a metal which would be reacting with an acid to give a metal salt, to give a salt and release a gas. That is hydrogen gas. That is a hydrogen gas. Is that clear to everyone or not? Priyanka and Abu, you guys getting it or not?
No, sir.
Not getting it. See, in this test tube, you have taken hydrochloric acid. And why we are learning about chemical properties, we learned in, like, you guys would have learned about chemical changes in which new substances are formed now. So we are learning how acid would be reacting with different substances to give out new things. How acid would be reacting with metals. Later on, we'll be learning about how acids would be reacting with non-metals, and what forms in the reaction, what are the products we obtain in the reaction. What was observed, if we were to take some granules of zinc, you took some granules mean basically small particles of granule. Okay, na? Zinc granules, basically these are small particles of it. And you have taken an acid, let's say here you have taken a hydrochloric acid. In short, it is written as HCl, that is hydrochloric acid. What was observed in this activity, that it started to release some bubbles. Those bubbles were actually the hydrogen gas that were coming out from the reaction, that was coming out of the test tube. As simple as that. That is the thing which is happening in this. So you took some granules of zinc in one glass test tube and added this acid in it, and what you found that that a gas was coming out of it right now. Now, what is the test that a hydrogen gas was produced in this? How did the scientists came to know this? So keep this thing in mind that hydrogen gas has got a very special property. Hydrogen gas has such a special property, like for example, when scientists brought a burning candle flame near to it, when we brought a burning candle flame near to it, so thereby what will happen? The hydrogen gas comes into contact with this now. This is, let's say, hydrogen gas, H2 for hydrogen. So when you brought it near to the candle, or you could candle flame, so it burned. The gas started to burn and produce a pop sound. Hydrogen gas started burning and produced a pop sound. So far, is it clear to everyone or not? Please tell me. If not, I will be repeating it. Abu, did
Yes,
you got it? Priyanka, did you got it?
yes, sir.
Sir.
So the conclusion of the experiment is that whenever a metal, zinc is a metal, whenever you have a metal reacting with an acid, thereby the product obtained will be salt and hydrogen gas. Let me circle these things. Metal plus acid gives you salt and hydrogen gas. So that is the thing. In fact, we could have done this activity. It was observed in case of some other metals also. For example, it was observed in the case of magnesium also. Getting it? If you were to take magnesium, that is Mg, magnesium, you reacted it with the, let's say in this case, let's take another acid, for example, let's take H2SO4. What is the name of H2SO4? Can you guys recall this? It is sulfuric acid. Okay, now
Okay, sir.
sulfuric acid. So magnesium reacted with the sulfuric acid to give another salt. The name of the salt was magnesium sulfate. Magnesium sulfate, that is MgSO4. Along with this, in this activity also, it was observed that hydrogen gas was emanated. Hydrogen gas was coming out from this. Is that clear to everyone?
Sir,
While both zinc and magnesium are metals. Yes, Priyanka.
can you wait for a minute? I'll rejoin.
Okay, sure. I will be waiting. Meanwhile, Abu, tell me, do you have any confusions in this?
No, sir.
Okay. Later on, so right now we did discuss that acids react. Let me write this over here. Acids.
Sir, I'm back.
Yes, Priyanka. So I was saying that acids react with metals to form salts, metals to form salts and release hydrogen gas. Or if you're finding it difficult to memorize, just remember this much, that acids react with metals to release hydrogen gas. To release hydrogen gas. I believe you guys have understood it, and um, don't forget it. Okay, now? So we have discussed that. Now, there are some more chemical properties, but I will be keeping it for the next class. later in the next class we will learn that how an acid will be reacting with a base. How an acid will be reacting with a base. Okay, now for example, if I were to take an acid and base, a reaction will take place between them also. The products I will be obtaining will be a salt along with water. So acids and bases, both of them are completely opposite to each other in the properties now. One is sour, one is bitter. Huh? One turns the blue litmus paper to red. One turns red litmus paper to blue. You can see from here. One turns red litmus paper into blue and one turns blue litmus paper to red. Then uh, their tastes are different. One is corrosive in nature, one is not corrosive in nature. Right now.
Yes, sir.
So they are opposite in properties, but once you react them with each other, so thereby they lose their properties. Acid will lose its property while base also loses its property. They become a neutral substance, and that is a salt. That gives you salt along with water. So that is the thing. Okay. So there are few questions I would like to ask, and then we'll be concluding the class. Do tell me, mention at least three physical properties of acids, Priyanka, and Abu, you also mentioned three physical properties of acids which we have studied today. Meanwhile, write this statement. Write the heading chemical property and write the first line. Acids react with metals to release hydrogen gas. Only write the first line.
Sir,
Yes, Priyanka.
hydrochloric acid,
Yeah.
uh,
Is that a question?
no, sir.
Complete your question.
It's okay, sir.
You guys are noting this thing or not? Give
Yes,
the
sir,
heading
I'm
chemical
noting.
property and just write the first line. Only that much. Also, you guys tell me, like, normally we have seen that metals are corroded by acids. Huh? Then how do we store acids, or how do we store acidic food in metals? So nowadays you will find that metallic containers made from brass or copper, they are coated with a layer of tin, tin, tin. It's a bright white metal. You might have seen it. And tin is non-reactive to acids. It does not react with acids. Hence, it will be preventing the food poisoning, preventing food from spoiling. Getting at what I'm trying to say.
Yes, sir.
And in fact, nowadays we have better solution apart from tin also. Like we make use of stainless